I did.
So enough of you want to come up here. I'm going to have to do random cards for it. All right, so Gus, your card is on top. All right, so because yesterday we did the post-it, so we're not resetting until we get all the way back around to Aiden's card. So if you would like to come teach us how this proves the Pythagorean, you can. But all right, I also did not finish my sentence, so while Gus thinks about it if he wants to come up. So a proof starts as a conjecture. So if we want to be able to prove the Pythagorean theorem, a long time ago, Pythagoras, right, because it's his proof, said, I believe that in a right triangle, the short leg squared plus the other short leg squared equals the long leg squared. And we talked earlier in the week about squared meaning, like, what's the real meaning of squared? And don't tell me multiply a number by itself. Connor?
Turning it into a square.
Yeah, literally take a length and square, like make it a square. Absolutely. So Pythagoras then would have been confronted by other mathematicians who said, prove it. How could he have done that?
I did,
Gus is carefully coming up.
yeah, I had them up, but then one fell off. Well, I did
There you go,
something
there's
like,
the camera.
or is this even in it? Okay, well, I did like that. I mean, it's not perfect, but...
Dude, well, what is that? Explain what you did.
Oh, I was just messing around.
How do you think this proves the Pythagorean theorem?
It does. Math.
It does math.
I know how.
Alright.
I can use the one he has.
Oh, okay. I leave.
Because it's all the lengths. So a square has all the same sides, and these are all the same triangles. Because A, B, and C are. So A squared. So there's A on each side. So here, to get the area of a square, you have to multiply the length of the two sides to each other. So, when there's A, okay, I hate words.
So do I.
So hold on, leave that there actually.
Oh.
I tried.
Amelia?
This is just another, point one of these out things. I think if you put all those triangles together, they also fit the area of that little square created. So just another little point.
Right, I'll bring up mine.
I was about to say, I have more.
Here, I'll bring up mine.
So you're wondering, Amelia, and I guess we could partner up.
Oh, I have
So this,
Oh, he's already got
this, this, and this. But it actually took, so the whole big square is how many of our triangles? It's 8 of the triangles. You can come on up, sure, Connor.
So, if you look, Brenda, you were going the right way.
I know, I just couldn't figure out
So
how
look,
to use
Words.
every side to the square is 1A and 1B.
So you mean like A plus B?
Plus B.
Yeah, because and, right?
Yeah.
And means plus.
Okay. And then if you think about it, like Brenda said, the way that you get the area of the square is multiplying once the height by the length.
So what Connor's saying, let's make sure everyone's on your page. This is B, this is A, so this is A and B.
So what it is A plus B times A equals B, which is...
So graph paper. Oh, you don't have graph paper? What, you thought today was a different day that we wouldn't use graph paper in math?
Yes.
So Connor is saying if we take A plus B and square it.
What lesson is this?
How dare you?
This is 927. We're going to try to be as smart as Pythagoras and prove his proof. Now, the other thing that mathematicians love to do is say, well, actually, so those of you who find yourself saying, well, actually, you might be a good mathematician because when you put a conjecture that you think is a proof out into the world, you publish it in like mathematical magazines, and or in the day of Pythagoras, you would like send it to people. You would say, hey, I think this is true, check it. If it's not true, your proof gets disproved, and it's not a proof. Right? So the fact that we can, or it's not a theorem. Sorry, so a conjecture has not yet been proven. A theorem is proven. Right? Like nobody has proven it wrong, essentially is what a theorem means. What's up? You want yours back?
Some markers.
Can you have markers? I got highlighters over there. I don't really have like markers.
I have markers.
I mean, I got Sharpies, but
Can I use some of those?
these are my pens, man. These are
Okay.
my. I can't start loaning out my pens. I loan out my markers, man, or I loan out my highlighters. So, sorry, Connor, you just said if I do a plus b squared, that tells me.
The right remote
That's
order.
the same.
Okay.
That is the same as equivalent to a squared. Yes.
I think you already said this, but I think you were about to jump over it. That means take a plus b and multiply it by itself.
So it's a times a plus b times b, which is a squared.
Close. Close. So here's something we don't know yet. Please write this down. You don't know this yet, and there's a trap door here. If I took a and multiplied it by a plus b, what would I get? A squared plus b squared.
What?
Wait, what?
Wrong, right?
Oh, okay.
A squared plus what?
B.
AB. Right? So wait. So when A multiplies by this binomial, I have two different variables. So A squared plus AB. Now wait. When B, if I just did B times A plus B, what would I get?
B plus b squared.
Ooh, BA plus B squared. So if, go ahead, we'll make dramatic pause. It does not sound like it's sharpening very well.
It's sharpened.
So,
Sorry, that came out.
when we multiply two binomials, I got some people not paying attention and I'm scared. It's not just going to be a squared plus b squared because the a multiplies by both the a and b. But also, the b has to multiply by the a and the b.
But then also the other two have to multiply to the A.
So it doesn't go both ways, right? So that's why we wrote out this one first and this one second. So what this actually does, there's a little trick that we use in math too, and I love over teaching you guys. So as we get to the end part of the year, I'm going to teach you guys some things that are not necessarily Math 8, but I promise you, when you then see it in your other math classes, Amelia, what are you doing? When you see it in your future math classes, you'll be like, oh, I remember this, right? And it's going to help you be able to learn it faster. The shortcut that we use on multiplying binomials is abbreviated using the word FOIL. So literally, and if you have older siblings and you go ask them like, oh, we did FOIL in math today, they'll be like, oh yeah, first, outside, inside, last.
What?
Oh my gosh, those are like the.
These are binomials. B-I-N-O-M-I-A-L. Like if you sound it out, it is correct, yeah. So this stands for first, outside, inside, last. Here's what I mean. Your firsts are a times a, right? Your first numbers. So I'd get a squared, like I got up here. My outsides are a times b. So I get a times b. Sorry, a times b, which I had up here. My insides, b times a. Is 2 times 3 the same as 3 times 2? So instead of writing b times a, what might be a little bit nicer, make it a times b also. And then what's the last? B squared. So if if we're going to talk about doing a plus b squared, we have to be very careful that we don't forget about these values.
Wait, so wouldn't it be a to the fourth times b to the fourth?
So wait, where are you getting a fourth power? This is a completely different number. A times b is completely different than a squared. Think about shapes. If this is our a, crap, I don't have any y's over here. We'll bail on that for a second. Okay, so you get a squared plus 2ab plus b squared. So this is actually what you get, Connor, if we do a plus b squared. So what we're saying is this area...
We got c.
We don't have a c involved here. I'm just doing what you guys tell me to.
We just do it.
We're in the middle of it, because I don't think we've, like, gotten to the end yet. So wait a minute.
We had to get rid of the 2b.
Or not 2b? So a times b. That would be a rectangle, right?
Unless A and B are the same.
So that is AB, right? A rectangle with lengths A and B. So wait, isn't this also
Oh my
AB?
god! So 2AB is equal to C.
So we have two ABs. So,
No, but
but wait, hold on. So we said that this is like,
no, that's the same.
do we
But
do we trust this?
No.
Yeah, I think I broke something.
Why did A
Wait, Jordan?
by looking at it, it looks like A equals or A equals C.
Wait, and does A equal C? I think we broke this. Why'd you guys let me do this?
I was just we broke Pythagorean theorem.
Does A equal C?
No.
I can't line these up like this. Guys, I was really like holding my breath waiting to see who was going to call me out. If A and C are not the same, I can't do this. So I can set up what I had set up.
What?
I can set up what Gus had set up. But I can't fill that space with those triangles unless I line up... What if I line up the C? Can I do this?
Yeah.
So I could do that.
Oh my.
Right, I could line up C with C.
Keep doing it.
So hold on. I can line up C with... Hold on. So what if I just got an idea? So I line those up. Right, now call me out if I break a rule. Guys, we're getting into the part of the year where, like, I make mistakes that you gotta call me on. So be careful. Don't just blindly trust the things that like, don't trust it till we actually, like, say, okay, this is true.
Don't trust you about it.
Yeah, don't trust me. It's yes. If you've trusted me up to this point, that was your own mistake. Or I mean, that was your own decision.
Wow.
So wait. So if I can I?
Yeah, then use the c, the another triangle and put it next to the c.
Okay. This is where I really don't like that you guys aren't in the groups. Sorry, Math 7 needs to finish their test today, so I didn't want to move desks around. So wait, so I can line up those. So, hold on. Take a couple more minutes. Just play with this, but you might need to pair up or triple up if you want more triangles. Wait. 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 Play with this. What's up?
I'm not sure, but like when you put all those together and like make the small square in the middle, I think that small square is the area of the triangle.
You mean this? That square in the middle?
No, like the small square. Like when you do that.
This? So this?
So No, like it would be like right there. But like if you
Here,
did
you-
this,
What do you want? More triangles? Yeah. You pair up with somebody, like work with somebody, share your ideas with each other.
just said like maybe I'm wrong, but it kind of looks like this.
Isn't that halfway?
Yeah, this is the same area as this.
Is that? I think that's.
So if we said that this edge is a plus b, this is true. We're allowed to do this. And then we get another triangle and check. Is that b?
I think. Yeah.
Because right now this is like 4ab. Hi.
Oh wow, that's
I don't know what. Ooh. Yo, Jordan's got something interesting going on. I don't know what yet to like what math to write. So hold on, Jordan. Tell them what you realized, and then we can have Connor share. I don't know if we've actually realized, aside from seeing that it looks cool.
Yeah.
Which, by the way, we do have FCO today, in case people missed that on the forum thing. FCO today. So Jordan, what do we think? Jordan's got a conjecture, right? He thinks.
I think that like when you make this shape, the inside square of this is the same area as one of these triangles, because this one side is b.
Wait, wouldn't it be b times b then? If it's a square, because you just called it a square.
And doing this, I just realized that b and b, so I think a is also 2b.
Or not 2b.
Oh!
All right, so interesting conjecture.
If I cut this up in the
Aside
middle,
from the crowd around my desk, we'll take Connor, but then we'll take Spencer. Well, okay, you can have him back if you really want, but
Okay, those are
or
out
I
of the way.
guess I could have grabbed another
Okay.
sheet. I meant to cut out more before
So-
class, but us
So,
teachers talk too much. All right, listen to Mr. Brown.
this is a familiar image, right? We did this on that video.
Scooch it up a tiny bit.
Okay, scooch it up.
Yeah, so they can see it. We saw this on that video, but it depends how much you retain from the video.
What video?
Oh, that's right. This is c squared and this is b squared. Which means
A squared.
Huh? Oh wait, no, this is a squared. Sorry. Which means okay, wait. I just forgot what I was gonna say. Nevin.
Yeah,
Shh, hold on, hold on.
Nevin. And I
I remember everything from the video.
Great.
And you're so,
So-
humble.
We have 4 identical triangles, right? They all have the same sides. If we arrange them like this, this square in the middle has to be c squared because all the sides are c. If we rearrange those triangles into these two things, then you have a squared here and b squared here. But since all of these are identical, right? They haven't changed their area, so a squared and b squared must equal c squared because they are always the empty space. Yes.
I know.
So,
I was just gonna say
hold on. What? So that's a conjecture that we might look at, and that might depend on the dimensions, right? Or does it always happen, Spencer? So you're thinking that a squared plus b squared, or no, that 1/2 times a times b, like the area of the triangle, is equal to b squared? Okay, interesting. Yeah, I mean, we can explore that, right? So hold on. Nevin, run us through that again real quick, but start right here, and then run us back to seeing c squared.
Okay. Since these are all equal, right? They take up the same amount of area. So if I rearrange them, they're still taking up the same amount of area.
So he's talking about the empty space that is left, in the square. Which, what he just had was an empty a squared and an empty b squared.
Yep.
But now that he rearranged them,
Now it's c squared. And the
Now
empty spaces must be equal.
And therefore, a squared plus b squared
Equals c squared.
squared. And now my head hurts. Thanks.
You're welcome.
so then what we have, oh yeah, that one's yours. I was about to say, don't take my triangles. What we have,
This is actually yours.
So it's Connor. It's Connor.
We're all stealing each other's triangles. But so here's an interesting arrangement that a couple of us were talking about up here.
Look, I know.
What if I arrange all of this, I've got AB, right? Rectangle AB. I've got 4 ABs. And then this is B squared. Well, hey, if we think that A is 2B, is there a way that we can, like, look at, is it? Can I check, is A 2B? So in this case, now that won't always be true, but in this case, looks like we've made this nice. Sometimes math is nice. Wait, so if I rearrange the area, oh, I have the same thing, except now I shifted where the empty square is. Okay.
Miss Hudson, I made it square with a triangle. Look.
Wait.
If you cut a triangle, you can make it square.
B square. You make B square?
Yeah.
Don't throw this in.
I can't tell if your sentence has ended or if it's just very
Long.
stringy and paused
And long.
throughout. So wait, what we just said is back to that A plus B squared, right, which is the original shape, equals 1, 2, 3, 4 times AB, right, those rectangles, plus B squared. But what we already said was this.
What?
Well, and you said you're what so fast. I think you're just, that's a reactionary what. If we think back to what we already wrote down, we said this, we learned about foiling, and we got that A plus B squared equals this that I wrote down in blue. We already said, like, we agreed on that. Nobody stopped me, at least.
A plus B squared equals that. Wait, no.
Guys, that song that you guys love to sing, this is where it all, like, really comes from, is stuff like this. So chill. That doesn't give you permission to sing it right now. But we're just exploring. We're playing with math. I want to try to do a lot more with this, or of this, with you guys as we get towards the end of the year. And you need to know about Pythagorean theorem. So I saw this opportunity. I was like, man, today could be a day where we just like play with stuff and kind of try to like guys, math is interesting, right? Like it's not like I hate that we in America, like we ruin math for you. I'm serious. A lot of teachers do a disservice to math and they ruin it. They act like you got to memorize stuff and it's all like, math is just interesting. It's beautiful. It's fun. And sometimes it's messy. And other times it works out really nicely and it's just a fluke, right? Like if B is half of A, like a couple people have said, that might just be this case. I don't think it's going to be every time that B is half of A, because I could draw you a right triangle where that's not true.
Do it right now. I dare you.
But if what we said is this, what could I do to both of these equations? I'm going to rewrite this in a different color. So we're saying 4AB plus B squared equals A squared plus 2AB plus B squared.
Isn't that what you just wrote?
Yes, but in the same color now. What could I do to both sides of this chubby bunny kitty?
Take away
Brenda?
AB.
Solve it!
Well, okay, but how? What could I do?
Okay.
Simplify.
How?
Math.
Take away B squared.
Anna, say it louder.
Subtract B squared
Sub-
from both sides.
Get rid of that B squared from both sides.
Then get rid of AB. Or 2AB.
So then what we have is 4AB equals A. Well, yeah, but if I don't have to write the multiplication symbol, right? Because if it's there is multiplication here and there is multiplication there, and I'm off the recordable. I don't have to write either of those multiplication symbols, but I can if I want to. Equals a squared plus 2ab.
You can take away the 2ab.
I can take away 2ab from both sides, can't I?
So it'll be 2ab equals a squared.
What are we trying to solve for?
We don't know.
What? Trying to solve for A or for B?
Mr. Hudson, did you just make your room a math playground now?
Yeah, I don't know what we're doing. We're just doing things.
What? I don't really know.
No.
Yeah, I have no idea.
It's like Gus said, because we do stuff.
Wait,
Yeah.
there's something else we can do.
Divide by
Square root would be real. So I'll listen to you, right?
No.
If we square root, we get a equals square root of 2ab. I don't think that's the cleanest way to get to what a equals. Divide by a. Sorry, I can't hear everybody at once. I'm sorry, my brain is limited. Divide by a. Because, guys, a squared is really just a times a. No, not 2a. A plus a is 2a. A times a is a squared. Okay, make sure that we have a clear difference of that. A plus a is 2a. A times a is a squared. So if we divide by a on both sides, giant 1, we get 2b equals a, and we just mathematically proved that yes, in this case that we just wrote down, our a is double our b. Brenda?
Oi, I have two quick questions. When a math problem is talking about a hypotenuse, does the triangle have to be a right triangle?
Yes.
Okay, thank you. That is very helpful. Also, you said we were going to work on the flat family house and the
Well, that is my plan. Well, I was actually going to offer up if people wanted to come up and talk about it today.
Oh, yeah.
I mean, this Maddie just shot her hand up. You're like never this excited. I feel like I have to call on you. What are you wanting to? Which one are you wanting to come talk about? The Christmas lights behind my house or the flat family? I mean, you look real into this, so I feel like I have to. So here, I will. I should be fair. I should. Wow, you guys are way too into math. You're like a bunch of nerds. You're.
Well, you're a math nerd.
All right, so I've called on. I don't want to put people on the spot, but let's have. Which one are you wanting, Amelia? So we can have you and Lily come up and talk about that. Maddie, why don't you come up and talk about the lights then? So I've got my drawing from yesterday, but you're welcome to bring up yours and show us and like help us out. Who what? Were you guys working together? Yeah. So I mean, if you want to come up with your paper and show that, you can, or Maddie can show hers. So hey, we're gonna leave that. Like, I would put this in your binder or something, but like, we're gonna leave this alone for now. This is just us doing more like math practice and playing and stuff like that.
Was this examples from class, like the fat family patio?
Where's the fat family?
No, it was examples from class.
Well, they're flat, they're really fat.
So if you want the easier way to draw on, do you want this picture and then you want to draw on this, or do you want Amelia's?
Oh, I can.
Because I see you with the pen about to draw. I'm probably going to switch over to Smartboard, so it's easier for you to draw on it.
Okay.
So I'm going to snap a picture of this real quick.
But Mr. Hudson, can we move the flat family patio?
Can you what?
Can we move the flat family patio?
I don't understand the question. Can you move? What do you mean move?
Yeah, just move the what?
Oh, the model. My beautiful art project.
The buddy box.
Master 15.
All right, so remember up here, Maddie, you're going to have to select pen to be able to write. Huh? I would hang on. Well, it's
Can I start with the
if
pen?
your binder has a folder, I would shove it in there.
And the skinny.
So basically, we know that it is 7 right here and 30 right here. So then, so to find this one, we need to do 7 squared plus 30 squared.
Just, I memorized what it is. It's,
And what is that?
I memorized what, it's 30 squared is 900 and 7 squared is 49.
What?
Yeah, I memorized it.
And then 30 squared.
Is 900. Well, 7 squared is easy.
Whoa.
Yeah. So that equals
Now.
149. And then what's the square root of 949?
Hey, there are too many people talking at the same time as Matt.
It's a rounded version. 30.
Wait, what's the
30.8. So then,
Like that's like rounded.
square root of that is
what?
30.
49.
Is that for the pink or is that for the blue?
For the pink.
Alright. So, anyone have questions on how Maddie found the length of the pink wire, like, of the pink triangle, really?
And
So then, do we want to let Amelia jump in and do the blue one?
but since both of these are the same, we know that they will both be around 30.8.
Sorry, I gotta reset my USB. That's why the pen keeps glitching out for you. So give me just a second. I'm gonna unplug this and plug it back in. Alright, try now. Click the pen again, like up top. Now it should work. Sweet, Amelia, you wanna jump in? I was about to say, I can do any calculating you need as well.
Oh, I
If you don't have enough hands.
We have to cut this one in half, as you see, 30 by 10. And so that's 3.5. That's still 30. And then so we can do 3.5 squared.
Just 12.25. I think you know what 30 squared is.
I'm just going to go by 30 squared up there. And then that's 900. And if we add those, we're going to get 912.25. And then we're going to have to square root that. So you've got
30.2.
30.2. And so then this line right there, this C would be 30.2. And so then this one would also be 30.2 because that's also another triangle right there, which is the same thing as that. And so then you have to add up the 30.8, 30.8, 30.2, 30.2, the 7 that's right here, and then with the 10.5, 21 right there. And this is the answer, which I kind of forget what it is, but I'll do it in there.
Wait, how much of the the side where there's 3 things, how much of that side is the
How much of the left side is what now?
how much of oh, this side has line.
Yeah, that has
All of it?
lights.
Oh,
Yep.
yeah, this
Yeah, that has
side.
lights.
And then it's just this side that has the lights. And that's 7. Then I think on my calculator, I don't know if I did it right, but it's 123.
Yeah, I don't have an answer key for this.
Okay, but yeah, that's.
I need to add them up myself, actually, because this is not a textbook question, right? This is just Chelsea's patio.
It's just
Well, I know. I haven't added them all up yet. You think when teachers write problems, we always get the answers?
Yeah.
If I know it's solvable, I'm just like, oh, I'll solve it later. Or there's a couple of you that I'll pull your paper, and if they both have the same answers, I'll be like, that's probably the right answer. You know what I mean?
Wait,
A few of you.
Wait, do you actually do that?
Sometimes. And then I check it myself, but yeah.
I was gonna say, I bet you there are some teachers
I will admit, on one test this year, I graded one student's test and made sure it was accurate, and then used that as my answer key because I hadn't made my own. Like I'm making the Math 7 answer key, or I hadn't made my own. I just used one of your guys' tests as the answer key. All right, flat family house. Ah, crap! I forgot today's classes are like. Well, you guys are only in here till 8. I'm used to you guys being in here till 02. Like 58. No, you go at 58. We can break this into 3 different parts, right? Because there are actually 3 different guy wires up here. So I committed to Lily that she could come up and do part of it, and then we'll go from there. Well, you came up for the lights. Whoa, I'm getting the book thrown at me. Just like what you said or whatever. So, if you don't color code, I think Brenda's gonna come up here and do it for you. Yes. So you should probably color code.
Okay.
Or code. I think it's code, isn't it?
So the antenna, we already know. We're going to be attaching the guy wires at 25 feet.
Oh, 30 minus 5. Okay.
Yeah. And this is, hold on, 60.
60.
It's 60, and the other, and over here is 32.
Feet. Right, the measurement.
You're allowed to have that. Yeah.
Yeah, these are all working numbers, right?
So,
don't be a pain.
So what we need to find is we need to find this so that we can split it in half so we can find
Oh. So, hold up. Let's make sure everyone's on the same page as you. Lily looked at the whole roof and the entire hypotenuse from here to here and just said, I can solve that using the numbers they gave me. So, with 60 and 32, what'd you get for that entire hypotenuse?
68 squared.
So, go ahead and put, or 68 squared or square root 68?
No, 68 squared. I knew it. I used my calculator and just checked it out on my sheet. So, 60 plus.
Oh, it's just 68. Yeah, the length of that across is 68 across the roof.
So, we now split that in half to get 34, and then we square that.
Okay, then how do you get the
Hey,
other
Jake,
measurements?
raise your hand. If people want to call on you, they will. If they don't, you don't need to talk.
I have this somewhere on my paper. Oh. Okay, we don't care about the 60. Hold on. We care about is the 25.
All right, so we're about to run out of time, but I will tell you.
It's
So, Lily, let me interject because I don't want to keep you guys late. I want to respect my other teachers, make sure I get you out on time. I will tell you, if you want a chance to come up and solve part of this next week, you got to come and show me your work written out. And I do not mean at the end of class because you have another class to go to. But if you want a chance to show the work to the class, you got to have the work on your paper. Have a wonderful weekend. You can recycle whatever you want if that's what you're about to ask. No, you're okay. Like, that's also why we're going over it all together. You guys can try it on your own if you want to. It was just like practicing, first off, identifying trap doors. Because the patio problem, there was like, people wanted to say, oh, these are all the same. No, they're not, if we're going to be accurate. Actually, you don't have all of your work written out with like showing a squared plus b squared and the different parts of the problem. Because, like, I don't know how you got to that.
I already did it. Right here on my work. Over the weekend. Can I show it to you? On Monday. No, I can do part of it. Please.
Probably, yes. It's funny, but like I don't have enough math problems to make everybody happy, I don't think, because there are more of you that want to show than there are pieces of the problem. You know what I mean?
Now I'm sad.
Well, I didn't say no. You guys, like, the amount of pressure you put on me to, like, let you do math. It's just, geez. Y'all want to do math. It's insane.